Morning, Algebra 2 students. I hope you're all doing well. Yesterday I had some office hours and there were 7 people that showed up. Nice job to those 7 that showed up and had questions. I mean, if you don't have questions, you don't need to go to the office hours, but if you do have questions, make sure to do that. This Friday I'll be doing office hours from 12 or noon to 2 o'clock, so it'll be an hour earlier than last time. So again, noon to 2 o'clock on Friday for office hours if you have questions on any of these problems or how to solve them, or factor in this case. So again, remember we're factoring in this problem here for our do now. It says factor the following expression completely. So think about how you're going to do that. So think about the first step that we want to do is, can we simple factor? So can we divide a number or variable from the terms? Then the next thing we want to look at is how many terms are there. So we want to count the number of terms. We can count that there's 4 terms. So what factoring method can we use for that? That's right, you can use left side, right side. And then are there any special cases? So after we start to factor, are there any special cases in the end? So let's look at this one more specifically. So again, can we simple factor? It's like, yes, we can simple factor this 2. All terms are divisible by 2. Also, all terms are divisible by one of the variables, so also a t, so a 2t. And then what's left over when we do that? So in parentheses here, we're going to have t cubed minus 12t cubed divided by 2t is going to be 6t squared. And then positive 6t squared divided by 2t will give us a positive 3t. And then negative 36t divided by 2t will give us a negative 18t. Oh, not a t. The t divides. So it'll be t to the 0, which is 1. So then now we count how many terms do we have. And we're not counting this outside term because we already factored that out. We're counting what can we factor in here. So we have 1, 2, 3, 4. So then 4 means that we're going to do left side, right side. So let's factor this left side. Let's factor this right side. So that 2t is going to stay out front. That's part of our solution, or part of what's one of our factors. And then we can divide both of these by t squared. And then we're left with t minus 6. And then what can we factor between a 3t and a negative 18? Yep, both of them are divisible by 3, and we'll be dividing a positive 3. So then we're left with, again, a t minus 6. 3t divided by 3 is t. Negative 18 divided by 3 is a negative 6. And then I need to put another parenthesis for this larger one, for that one in the front there. So now I can see that I have the same factor. So t minus 6 is a common factor, so I can factor that out. And that larger parenthesis will no longer be there. So I really have 2t times t minus 6. So there's 2 factors. And then another factor is t squared plus 3. And then this, again, is not something that it's not an equation, so we're not setting it equal to 0. So are there any special cases? Well, let's look here. So we're looking for squareds or cubes for special cases. So again, we're looking for like an a squared minus b squared, or we're looking for an a cubed minus b cubed, or we're looking for an a cubed plus b cubed. So those are the patterns we're looking for. The only one that comes close, t squared plus, tells us that it's not going to work. 3 isn't a perfect square either. So that means that there are no special cases, so this is going to be our final completely factored expression. So again, factoring the expression completely. All right, so let's look at our agenda today. So again, office hours, like I said before, they're on Friday, and they're from 12 to 2. Again, if you have questions, I mean, I can still share my screen and still use the pen, and we can go through problems, like in homework problems or past problems. It doesn't matter. what you end up doing. So, and then we'll look at factoring three terms. So we already know three terms. If we have three terms and it's quadratic-like, then we can do RS methods. We're going to be looking at that today. We'll do some more practice, look at the homework. I'm sorry, we'll have practice, a homework assignment, and then you'll be able to correct your assignment. And then this one, today we're going to factor polynomials using the RS method and more special cases. So special cases, we're going to see how that falls into there. I don't know if anybody checked out this last time. One thing you need to know is 14, if you know somebody that's in the military, you may know what this means. So let's move on. So factoring more special cases, I put more in parentheses because it's not necessarily that much more. We're just going to be looking at, instead of it being x squared or x squared, can we write x to the fourth as something squared? So it's going to be a little bit more involved here. Again, when we're factoring methods, simple factoring, we have any amount of terms. So, oops, that's ant terms. That's interesting. So any amount. And then the thing that we're looking at are the number of terms. So number of terms. So simple factoring, any amount can be simple factored. Special cases, we have special cases that have two terms. RS method, we're looking at three terms. And left side, right side, we're looking at four terms. So we first want to identify the terms, and then we choose the method that works best. So we have two terms here. Can we simple factor? That's any amount. Can we divide a number? Nope, 16 and 81 don't divide by the same numbers. Okay, so now we're looking at special cases. Is this a difference of squares, difference of cubes, or sum of cubes? Well, it's not sum because that's not a sum, that's a difference. Is this a cube though? We're like, no, that's not a cube, but is it a square? And I'm going to show you how this can be written as a square. So 16 is the same as 4 squared. So we can write 4 squared. And actually x to the fourth we can also write as a square. That's going to be x squared squared. I know that's pretty mind-blowing. So x squared can also be written as a square. And then 81, so we'll put a minus sign here. And then 81 we know is the same as 9 times 9, or 9 squared. So our a term in this case, and let's clean this up here a little bit, and let's write 4x squared squared. So I'm just kind of factoring out that exponent there, and then minus 9 squared. So notice that now my a term, my a squared part is 4x squared, and 9 is my 9 squared. So that's my 9 is my b. So how I write this is I write 4x squared minus 9, and then I write 4x squared plus 9. Because remember, for that special case, it's a minus b and a plus b. All right, so and this is one of the hardest parts about factoring completely, is that we have to ask ourselves again, are there more special cases? So we can already see that this plus sign, it's squared. It's like, that's not going to be anything because we don't have sum of squares. But is this a difference of squares? Can 4 be written as a perfect square? And we're like, oh yeah, it is. It's 2 squared. So we really have 2 squared x squared. And is 9 a perfect square? Yeah, that's 3 squared. So this is one of those like really special cases where it's like you have to do double special case to it, which is fine. There aren't many of these, but they do exist. So we have our, this factor we know it's not going to change, but this one's still going to change. So we really have 2x is being squared minus 3 squared. So, and you may already be finding the pattern if you're not doing these intermediate or these steps in the middle here, that's okay. So we know that a is 2x and b is 3. So it's really going to be 2x minus 3 and 2x plus 3. And the order of these two doesn't matter. If you wrote 2x plus 3 and 2x minus 3, that's okay. And then we have our 4x squared plus 9. So this is completely factored. Notice that it took us a while to get there. It's because we had two special cases. We had a special case of 4x squared minus 9, and then also the original one, the 16x to the fourth minus 81. So this is, and I show this one because this is probably going to be like the most difficult type of one that would be if it had double special cases like that. All right, let's look at another problem, and this one we're actually going to solve. So we're going to solve the equation. So first thing we want to do is we want to set it equal to 0. So let's set 10x to the fourth equals 40 equal to 0. So that means we're going to subtract 40 to both sides. So if we subtract 40, we're going to have 10 x to the fourth minus 40 equals 0. So what do we have to do can we simple factor first, right? That we're always thinking, can we simple factor? We're like, oh yeah, we can divide both sides by 10. I'm sorry, not both sides. We can divide the problem by 10. So notice that we have x to the fourth minus 4 equals 0. And then our next question is, can we, do we have a difference of squares here? Because I see I have two factors, so I'm thinking special cases. And we just talked about difference of squares. It's not a cube. So let's try to rewrite this. So this 10 outside here, we have, so what I did last time was I wrote x squared and then squared. 4 is the same as 2 squared. So minus 2 squared equals 0. Again, we're solving this. And then let's rewrite that. So now we have x squared minus 2 as one factor and x squared plus 2. Can we factor any more? You may be thinking, oh no, we can't factor anymore. This isn't, 2 isn't a perfect square, and this isn't a minus. So now we need to check out our solutions then. Remember in the beginning here, this 4 tells us that our degree is 4, or n equals 4, which means that we have 4 zeros. We're going to have 4 solutions. And remember, in polynomials, some solutions are positive, or I'm sorry, some solutions are real, some solutions are non-real. So let's set these parts with x equal to 0. If we divide both sides by 10 right now, notice what happens here. 0 divided by 10, that still stays 0. And 10 divided by 10 becomes 1, so that just cancels out. So we really have x squared minus 2 and x squared plus 2. We could have done that at the very beginning. Instead of doing this, we could have just divided the whole thing by 10, and then that would have canceled out, and that would have turned into a 4. So we could have done that at the beginning. We didn't, but we can get rid of it now. So now we have to solve these two parts. So we have x squared minus 2 equals 0, and x squared plus 2 equals 0. So in order to solve, this is a quadratic, 2 terms for a quadratic. So what process are we thinking? That's right, we can use we can use definition of square roots, or we can also use quadratic formula. So whatever one you want to use, let's use definition of square roots. That's going to be most efficient. So x squared will add 2 to both sides. So x squared equals a positive 2. And then x will equal plus or minus the square root of 2. Does square root of 2 simplify? And we're like, nope, so this will be 2 solutions. And then this next one, we have x squared. We'll subtract 2 to both sides. So x squared will equal negative 2. Definition of square roots tells us something squared equals a number. Then that thing, x, equals plus or minus the square root of negative 2. Can we simplify this? And we're like, oh yeah, that's right. We can write this as x equals plus or minus square root of 2, square root of negative 1. We know that square root of negative 1 equals I. So we're going to write x equals plus or minus square root of 2 I. So notice that we have 2 solutions here, 2 solutions here. And does that add up to our total number that we expected? Yes, it adds up to 4 total zeros, some real, some unreal. And we can write this we can still write it in set notation. So we can write we can still write x equals, and the notation here can look a little different. So um, we'll just put it in like this, and we'll put our real numbers first. So we'll put plus or minus square root of 2, and then plus or minus square root of 2i. And that would be our solution. 2 zeros, 2 zeros, that's all 4 zeros. It would also be appropriate if you just circled up here too. If you just circled that one and that one. Remember, the set notation is just so that you get used to using that or seeing that in things. All right, so let's move on to our, so that's looking at more special cases. Now let's look at factoring 3 terms. So again, simple factoring, we know that that's any amount. And I write this on, oops, and, that's not any. All right, so any amount. Special cases, we know that special cases, that would be for, that would be if we have 2 terms. RS method would be if we have 3 terms. Left side, right side factors 4. So again, this is our number of terms. So how many terms do we have here? And we're like, oh, we have 3. So we're thinking, can we factor this using the RS method? But that's not our first step. Remember, our first step is always a simple factor. So what can we divide all these by? That's right, we can divide them all by a 2. So 2 divides by 2, 10, and 12. But also, can we divide by the variable? And we always look to see, we always divide the lowest number. So p squared is what we can divide all these by. So we can actually factor out a 2p squared. And then what are we left with? We're left with p to the 6th power plus 5p to the 3rd. And then we're left with plus, so this would be 12 divided by 2 is 6, so plus 6. And then there's no p's left. All right, so is this quadratic-like? So factoring 3 terms, we want to look at something that's more quadratic-like. So quadratics we know are something x squared plus x plus our constant term. But what if we had something that was like x to the 4th plus x squared plus the constant term? So this also is quadratic-like. And let's say that we raise this this x squared here to x to the 3rd. So it would be like x to the 3rd. And then this, instead of being a, so it's 2, 4, and then notice that this has to be twice as many. So this is going to be x to the 6th power. So notice that we have a pattern that's like this. We have something to the 6th power, we have something to the 3rd power, and something, and then we have our constant term. So we can do the RS method. So remember, it's R times S equals our A term, which is 1, times our C term, which is 6. So R times S equals 6. R plus S equals our middle term, 5. So then what 2 numbers multiply together to equal 6? Well, we know 2 and 3 do. We also know 6 and 1. And then we need these to add up to 5. So of these ones, which ones add up to 5? We're like, oh, 2 and 3 add up to 5. So then that's going to be our R and S. And what do we do next in the RS method? That's right, we stretch the middle term. So we're going to stretch this middle term. And notice that the middle term is p to the 3rd power. So we're going to be stretching p to the 3rd power. So let's write this 2p squared on the far part here. I'm going to give us some space just so that we know what we're factoring here. The a term doesn't change. The b term gets stretched. So now it's going to be plus 2p to the 3rd. And then plus 3p to the 3rd. Common mistake is to write p here because we're so used to stretching the middle term as p that we forget that it's p to the 3rd. And then plus 6th. All right, so now notice that this is like, oh, we're factoring still, we're factoring left side, right side. We have 4 terms. So now we're factoring left side, right side. Still have our 2p squared out front. What can we factor here? That's right, we can factor out a p cubed. And then we're left with, that's right, p cubed plus 2. And then this other one, we're going to factor out yep, that's right, a 3, so plus 3. And then we have a p cubed plus 2. This last parenthesis from that first one. All right, so we have a common factor here, p cubed minus, or I'm sorry, p cubed plus 3. So let's write that original one, so 2p squared. We have a p cubed plus 2, p cubed plus 2, and then we're left with a p cubed plus 3, p cubed plus 3. All right, so now at the very end, remember, after we do some factoring, we always got to check for special cases. So do we have any special cases? Well, I see some p cubes, and again, we're looking for an a cubed, in this case, plus a b cubed. So we see an a cubed, we see a plus, but do we see a b cubed? And we're like, well, 2 isn't a perfect cube, and neither is 3. So then we don't have this special case. So that special case doesn't apply here either. And then this is our final answer. Notice that if we add up our exponents right now, we have, and we add them up because they're factors. Notice that we don't add them up when they're written out in standard form, just when they're factors. So after we factored completely, let's add these up. So we have 3, 3, and 2. That gives us 8. So it gives us the number of zeros that we had. If we were solving this one, we would solve for 8 zeros. That means that it's crossing the x-axis 8 times, or there's some zeros that are also going to be what am I trying to say? Oh, unreal zeros. So we can have some real zeros, some unreal zeros for those 8 zeros. All right. So this next problem says to solve the equation, and what first thing we have to do is we have to set this up by solving the equation. So let's set it up. Let's write, and when I say set it up, we have to set equal to 0 first. Remember, so our first step is to set equal to 0 when we're solving. And then our second step will be to simple factor. Our third step will be to count our terms and decide on the method of factoring. So our method to factor. And then our fourth step, after we do that method of factoring, we want to check for special cases. We always check for special cases. They're hidden everywhere. And then our last step is we want to solve. And we're just going to, again, solve for our variable. So solve for t. All right, so let's look at this problem here. So we notice that we're not set equal to 0. So when we subtract this over, we want to make sure that we rewrite in order. So we're subtracting 20t to the 4th. So it'll be minus 20 t to the 4th, because that's the next power that's largest, and then plus 24 t squared equals 0. I'm just going to move this part a little bit higher. There we go. All right. So so now what can we divide? That's right. We can actually take out a 4, all there is by 4, and we can take out a t squared. So then we're left with t to the 4th. We're left with negative 20 divided by 4 is negative 5. T to the 4th divided by t squared is going to be t squared. 24 divided by 4 is a positive 6. And then t squared divided by t squared, it's gone. So notice how fast these problems actually do simplify. All right. Is this in quadratic form? Remember, quadratic form looks like x squared plus x plus c. It looks like x to the 4th plus x squared plus c. And it also looks like x to the 6th plus x to the 3rd plus c. And it's really, if we just say that this is n, it's really, and we can write this for all equations, it's really x to the 2n plus x to the n plus c. So you put in any number here, and if it's 2 times that number here in this first term, then we can do quadratic, or then it's quadratic-like. So this is really our, and this would be a way if you're writing it for all possibilities. All right, so we have x to the fourth, I'm sorry, t to the fourth, we have a t squared, and we have to try, so we simple factored, now we're looking for a factoring method. We have 1, 2, 3 terms, and it is quadratic-like, so let's try to factor that. So we have to check our RNS. If RNS doesn't work, then we have already done all we can do. So we have r times s equals 6, r plus s equals -5. All right, so factors of 6 we already know is 2 and 3, or it could be -2, -3, and then it could be, it can't be negative 6, +1. It could be +6, +1. So -1, -6, or it could be 1 and 6. And then which ones of those add up to -5? It's like, oh, this one does. So I was listing out all the possible factors. You probably found that before I got there. All right, so 4t squared. Stretch the middle term with that -2 and that -3. So we have t to the fourth minus 2t squared minus 3t squared plus 6 equals 0. How many zeros are we looking to have in this one? That's right, 6, because n equals 6. So we're looking for 6 zeros. All right, and remember, some could be real, some could be unreal. All right, so now we have 4 terms. So we have left side, right side. In the RS method, we can factor out a t squared. I forgot to write the 4t squared out front. Don't want to forget that. And then we have t squared minus 2. We can take out a -3. And then we're left with, again, t squared minus 2 equals 0. All right. Keep going, keep going. So we have t squared minus 2. Oh, my 2's are getting sloppy there. Sorry about that. We have t squared minus 3. I have my 4t squared out front equals 0. So now, do we have a difference of squares here? We're like, no, 3 and 2 aren't difference of squares. This is just going to be as it is, so we can't factor anymore. So now we check special cases. Now we're going to solve for t. So 4t squared equals 0. Oh, that's just 0. If we put 0 in there, so t equals 0, and this is repetitive, so that's actually a repetition. So that happens twice. And then we have t squared minus 2 equals 0. Definition of square roots. T equals plus or minus square root of 2. All right, and then we have t squared minus 3 equals 0. T squared equals positive 3. T equals plus or minus square root of 3. So then our final answer, we have t equals, and then in this case we have 0. That's repeated twice. We don't need to write it twice though. And then we have plus or minus square root of 2. And then we also have plus or minus square root of 3. 2 zeros, 2 zeros, 1 0, but it's repeated. So 2 plus 2 plus 2 gives us 6. We were expecting 6 zeros, so that would be our final thing. All right, so those are the problems today. Those are 5 of them. Notice that they're getting pretty long. So our answer key for practice 3, here's 1, 2, and 3. And then 4, 5, and 6. I'm sorry, 4, 5. And then your homework assignment, we have 6 problems today. So here's 1, 2, and 3. Follow those steps that we did in class. All right, and then here is 4, 5, and 6. All right, and then something that we want to start noticing now for our ticket out is what factoring method will you use to factor an expression with 4 terms, so write that method out here. So what method would you use? For 3 terms, what method would you use? For 2 terms, what method? Any amount of terms, what method? So what method would you use? Just write those out. I hope you all have a great day. Sorry this video got a little long. These ones take a little bit longer to solve, especially when we're finding all these special cases and things. Have a great day. I'll see you Friday, hopefully. If not, if you can't make it, that's okay. If you have questions, ask people that went to it, or use your friend groups. Talk to you later. Bye. Also have a great spring break. I hope you do something. Make sure to get out and move around some too, with 6 feet around you, so that nobody else can. Well, just to keep yourself safe. Talk to you later.